Hello, welcome. You may have seen one of these before. This is an arcade button. And if you don't already have this button with these two tabs soldered, then go to the video where I show you how to put this button together, put it together, and then the video where I show you how to solder it. What we're going to do today, though, is not solder it, because you've already done that. We're going to wire it into the Raspberry Pi, and we're going to detect when you press the button with Python. Okay, what do you need to know? There are three connections here where you can solder it to. We're only going to use these two. And just to show you how this works, this one here is the common connector. This one's normally open, and this one's normally closed. On the inside, it looks like this. So, normally, if you're not pressing the button, then the common connector is connected to the normally closed one. And then when you press the button, it connects it to normally open. So we will connect one wire to here and one wire to here. And when you press the button, bada bing, bada boom, it's like these are connected, because they will be when you press the button. Okay, what does it look like? First of all, line up your Raspberry Pi so you've got the USB ports down the bottom and match it to the Raspberry Pi pinout. If you Google Raspberry Pi pinout, you will get a picture like this one. We need to connect the normally open pin. We're going to detect the voltage of this on our Raspberry Pi using Python. And we could pick any of the BCM pins, but I'm going to pick pin 2. So you'll see pin 2 up here, it's second from the top, so that's this one here. So connect that one to pin 2. You'll need a female-ended breadboard jumper wire to get to there. Okay, so that one's connected there. And the other one that we need is the common connector, because when you press the button, it's as though these two are connected. The common connector, we will connect that one to ground. Now, if you look on our board here, we have a lot of ground. We've got ground, 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 ground. And the reason is because so many different components might need ground. So you can just pick whichever is the most convenient for you, maybe easy to find, or one that's not already used. I'm just going to pick this one, the bottom left, because it is so easy to find. Interestingly, it doesn't matter which way these two are connected, because there are only two states they can possibly be in. Either they are not connected at all, or when you press the button, they're connected. So you can actually swap that one with that one. I don't know why you want to, but you can. It would make no difference. All right, so now that you've got that wired up, let's have a look at how we connect them. So how we program them using Python. So, wrong one, there we go. What we're going to use is Thonny as a Python editor. We will need to run it as sudo Thonny, so that we can access the pins. It might work without that, but you'll probably have other issues. So let's just do sudo Thonny to run it as a super user. All right, so now what? Now how do we access those pins? What I normally like to do, just to show you how I would find this out, and in fact, how I did find it out, is to go online and look for Raspberry Pi button. And there's a great Python library called GPIO0, General Purpose Input and Output 0. Cool. There we go, GPIO0. And there are a whole bunch of tutorials of sample code that we can use. There we go. So this one turns an LED on or off. This one is close to what we want. You can see that it loads the LED part of GPIO0 and some pausing code, creates an LED on pin 17, a button on pin 3. And when you press the button, it turns the LED on. When you release it, it turns the LED off. But there is an issue. And the issue is that, well, number one, our button's connected to pin 2. That's an easy fix. And number 2, we don't have an LED connected. Now we could go connect an LED, but I'm going to show you an alternate way. Right, we will do something similar though to this. We are going to, from GPIO 0, we're going to import the LED class and the button class. Actually, we don't even need the LED button class. We only need the button. We're also going to, from signal, import the pause function. And just to check that this worked, maybe I'll print hello, run my code. I will need to save my code in order for it to run. It'll ask me for a good name. I might call this button test.py. Seems like a sensible name. .py because it's a Python file. Okay. Cool. Excellent. Okay, good. I just wanted to test that it doesn't cause any errors at the moment because it's easier to debug it if your program is really small and you catch the bug early. Okay. I might make this a bit bigger to make it easier for you guys to read. There we go. Even bigger. Why not? Let's go large. Oh, okay. Awesome. Right. We want us to create the button. Our button was on pin number 2. And we can say button.when pressed equals, and what goes here has to be a function. There is a function called on if you have an LED, but we don't have an LED. So let's make our own function at the top. Let's call our function button down. So to define a function, you do as word def, but define the name of the function, 2 brackets, and then a colon, which is the 2 dots. All right, so when you press the button, let's say, I am down. Oh, well, that's sad for the button. So now let's say when you press the button, then run that function, run the function button down. Okay. Now, if we do this, the program will instantly run, get to the end, and quit because it hit the end of the program. So you won't actually notice it when you press the button. So let's pause at the end. And that will just stop the program. It's similar to doing an infinite loop. If you've seen an infinite loop before, this does nothing at all, just over and over again. If you're not sure what that is, you don't have to know. You can just pause. It's much easier. Okay. Now let's run that. That's promising. So it's defined the function, but hasn't run it yet. It said button is a new button on pin number 2. We've called it button. This name you can call whatever you want as long as you're consistent. And when you press that button, run the function called button down. Now I'm going to press the button, but to make it easier for me to press the button, I'm going to do this. I have a female breadboard jumper wire. And if you don't have a button or you're not sure if your button's working properly and you want to troubleshoot it to figure out the problem, try this. You just connect one of these wires to, what did we have? We had pin 2 and ground. It'll connect them together. What this script is really doing is detecting if pin 2 is connected to ground. And if it is, it runs this function. So I'm going to do that. I'm going to take a wire to pin 2 in ground. You can probably, for yourself, just choose the arcade button. But it's fun to try both, check that both work. Now if I do that, hopefully... Oh, silly, my wire fell out. Hey, get back in there. What a sneaky wire. It does not want to follow instructions. That's right. Yay! How cool is that? It does something when you press the button. Yay! All right. Now let's see if we can do something when we release the button. Def button release. Maybe when you release the button, we can say, I am up. Yay! Happy button, up. That won't do anything by itself. But now if I say that same button, but when released, equals run the function called button release. Stop this. I'm curious if I could have a look at what button is. No. Oh well. run the button, run the program. So I'm guessing that it started now. Sometimes it's good to put a print statement in, like running program or something, or about to create button, just because it's hard to know what's not working. Let's stop that again. You can also press the debug line as well. And if you run it after the debug line, there's other cool stuff you can do. All right, so about to create button, and I guess it created the button. So now, if I press my button, yay, wicked. All right, good. Anyway, that is how you make a button do something. See you later. Bye, everyone.